I'll assume that you're familiar with statistical hypothesis tests and how they're applied in VSP. If not, please watch the video SH100 before continuing. If you've already gone through the sampling design process and are ready to test the sample results using the MARSSIM WRS test, refer to video SR300. The MARSSIM Wilcoxon rank sum, or WRS test, is a two-sample test that compares the distribution of a set of measurements in a survey unit to that of a set of measurements in a reference or background area. The MARSSIM WRS test is used to test whether the true median in a survey unit population is greater than the true median in a reference area population. For more information about the appropriate use of this test, refer to the MARSSIM manual at the website displayed below. In this video, I'll discuss how to use VSP to set up the MARSSIM WRS test sampling design. Since we're comparing a site median to a reference or background median, I want to set up a couple of sample areas for demonstration purposes. I'll create an elliptical sample area to represent the background. For help with creating sample areas, see the video EA100. I'll change the name to background and the color to green. I'll change the area type to reference area. If you leave the area type undefined, VSP will ask you which sample area is your reference area when you open the sample design dialog. I'll set up a rectangular site sample area and change its name to study area and set its area type to survey unit 1. Go to sampling goals, compare average to reference average. This dialog covers several statistical tests for comparing a true mean or median to a reference mean or median. To use the MARSSIM WRS test, state that you cannot assume the data will be normally distributed. This design will apply to the first analyte. For information about working with multiple analytes, refer to video S400. This portion of the dialog is where we set the null hypothesis. In most cases, you'll assume that your site is dirty. That is, the difference between the true median concentration of the site and the true median concentration of the reference area is greater than or equal to the action level, until you can provide enough sample evidence to confidently prove the site is clean. That is, the difference between the true median concentration of the site and the true median concentration of the reference area is less than the action level. The purpose of the sample design process is to make sure you gather enough samples to prove your site is clean if it really is clean. If you don't provide enough evidence, you'll have to continue to assume your site is dirty. The next section of the design dialog is where we control the type 1 or false rejection error rate specified as alpha. The confidence is the complement of alpha. I'll say the stakeholders want a minimum of 95% confidence, or a maximum of 5% alpha. The next box is the action level. This is the difference between the true site median and the true reference or background median. In this example, I'll say it was 5 units. That is, if the true site median is 5 or more units above the background median, it will trigger some further action, like remediation. The next part of the dialog is where we control the type 2 or false acceptance error. We start by specifying the lower bound of the gray region, or LBGR. Let's say the stakeholders decided 3 units was an acceptable bound. This next entry is the type 2 error rate specified as beta. I'll say the stakeholders want a maximum of 10% beta error. The final piece of information needed is an estimate of how variable you expect the sample data to be. The MARSSIM WRS test assumes that the variability will be the same in the site and the background areas. I'll say we have sample data from a similar site and it shows a standard deviation of 3 units. At this point, VSP is able to compute that you'll need to take 53 samples in order to meet all the objectives that we set. This includes the 20% inflation factor required by MARSSIM protocol. Also notice that 53 samples will be placed in the survey unit and 53 samples will be placed in the reference area. The MQO button is useful if you have detailed standard deviation information about both the sampling variability and the analytical variability. Pressing the MQO button allows you to split the 2 types of variability and perform multiple analyses per sample. Press the Apply or OK button to apply this design to your project. Let's switch to the graph view. Note that the x-axis shows the difference of true but unknown medians. That is, how far the true site median is above the true background median. The vertical red line is our action level at 5 units above the background. We see the gray region with its lower bound at 3 units above background. The red curve shows the probability that the statistical test will conclude the site is dirty for the range of true but unknown median differences. So if the true median difference is 7, the test will virtually always show the site to be dirty. And if the true site median difference is 1, the test will virtually always correctly say the site is clean. But for these areas near the action level, the test might make mistakes. This point on the curve at the action level shows the confidence. The distance to the top depicts the maximum alpha error. The point at the lower bound of the gray region depicts the maximum beta error. Note that the y-axis gives the probability as a proportion from 0 to 1, rather than as a percentage.